Hello to all. A warm welcome to my new session on data structure using C. PCA second semester NEP syllabus. This is a session number 5. Chapter 3 Queues and Recursion. Then let me know about what is an queue. A queue is an ordered collection of items where an item is inserted at one end. That end we can call it as a rear end, and an existing item is removed at the other end. That end is called as front end, so that the queue maintain the first in first out order properly. So that is also called as the first in first out list. Here the insertions are limited to one end of the list. That end we can call it as a rear end, whereas the deletions are limited to another end, that is called as the front end. So that in other words, the queue is an ordered collection of an items where an item are inserted at one end and deleted at the other end. This is we can call it as the queue. So this is the diagrammatic representation of the queue. This is the whole we can call it as in the first in first out basis. This is the end we can call it as a rear end, and here is this end we can call it as the front end. The process of inserting an element into the queue, that is we can call it as a NQ, and the process of removing an element from the queue, that is called as the DQ. So here the one by one elements are to be inserted into the queue. The first 40 element is inserted, then 30 element is inserted, and 20 element is inserted, then 15 element is inserted, then 10 is inserted. There are the different types of the queues which are present in the data structure. The queues can be classified into the 4 different types: simple queue, circular queue, priority queue, DQ. The DQ we can also call it as double-ended queue. First, let me know about what is a simple queue. Simple queue can also called as the ordinary queue. In the ordinary queue, the insertion occurs at the rear end of the list and the deletion is occurs at the front end of the list. So this is a diagrammatic representation of the simple queue. So here is that insertion which is always takes at the rear end and the deleted at the front end. So here the one by one the elements are to be inserted. The first 0 index and 1, 2, 3, 4, 5, 6, 7 and 8. The elements are to be inserted at this portion. The first is A element is inserted at the one position, and the second one B is inserted at second position. The next element C is inserted at the third position, and so on. At the end of the list, the E is inserted at the rear end. That position is at the 5. So that the front position which is equal to 1 and rear position equal to 5. Second type is that circular queue. Here, the circular queue is a queue in which all the nodes treated as the circular fashion, such that here this is a last node which follows the first node. So here is that the highlight has to be showed. So here is that the last node which follows the first node. So this type of a queue we can call it as a circular queue. So in this diagrammatic representation, the rear position is at the position is 1, the element is F, and the front position is at the position 4, the element is D. The third type is the priority queue. So priority means that is the precedence. Here the priority queue is a queue that contains the items have to be some present priority. Depending upon that priority, the element can be inserted or removed from any position. This type of a queue we can call it as priority queue. The fourth type is that DQ. We can also call it as a double-ended queue. It's a queue in where insertion and also the deletion, which is always takes place at the both ends. This type of a queue we can call it as an the D queue. We can also call it as a double-ended queue. So this is a diagrammatic representation of the D queue. So this the end is always takes place at an insertion process and also the deletion process. So here also the deletion and also an insertion, both operation is always takes place at this end. The next slide, we move on to the operations on the queue concept. So these are all the some of the operations on the queue. The first operation is queue. Queue, it creates a new queue that is an empty. The queue, it creates a new queue that is an empty. Here, there is a no need of a parameters and there is a no return in empty queue. Second one, enqueue. Within an enqueue, the parameter is an item. It adds a new item into the array of queue. That process we can call it as a enqueue. It needs an item as a parameter and returns nothing. So this is similar to like the push operation in this type. Third is dequeue. The dequeue, it removes the front item from the queue. It needs the no parameter and returns an item. So then the queue is modified. This operation is similar to like the pop that is in the stack. Next operation is empty. Is empty, it tests to see whether the queue is empty or not. Here there is no parameters and return the boolean value, either it is true or false. Then size. Size returns the number of items in the queue. Here there is no parameter and returns an integer value, which means that how many number of an item present in the queue. These are all some of the different operations on the queue. So here is that the memory representation of queue using arrays. Then what is an array? Array is an ordered collection of the homogeneous elements of the same data type under the same name. Here the queue is represented in the memory as in the linear array fashion. Let the queue is a linear queue. There are the two pointers are to be present in this representation. One is an front and another one is a rear. The pointer variable front, it contains the location of the element to be removed, and the pointer variable rear, it contains the location of the last element to be inserted. Here there are the two conditions are to be present. The one is that the front which is equal to null. The front which is equal to null, this condition is indicated that the queue is an empty. And one more condition is rear equal to n. So it indicates that the queue is a full. There are the two very important conditions are to be present in the memory representation of the queue using an arrays. So here is the diagrammatic representation of the memory representation of the queue using arrays. In the first representation, this representation, there are 4 elements in the array A, B, C and D. The front position is at 1 and the rear position is at 4. Then the one more element is inserted to this queue. That means the element is E. The first you have to increment at the rear pointer. Then you have to inserting the one more element into this queue, so that the rear position is incremented by the pointer 1. Then E element are to be inserted. Then the front which is equal to 1 and rear is equal to 5. Next, this process we can call it as that the enqueue. Then here is that the second statement, the process of dequeue, that is deleting an element from the queue. Here is that the item is queue front element, that is a that is copied to an variable item. Then front pointer is also incremented. So this diagram which shows that here the front pointer is moved to the next position because the A element are to be deleted. Then here is that the rear position is same. So this process we can call it as the DQ, so that the front which is equal to 2 and rear is equal to 5. Then we move on to the next slide. Here is that memory representation of the queue using the linked list concept. So linked list is the collection of the nodes. Each node it contains the two different parts. The first part contain the information field. Second part contain the link field. Information it contains the data, and the link field it contains the address of the next node. The queues are also represented by using a linked list. In the queue, an item should be inserted from the rear end, and an item should be removed from the front end. Here also there are the two pointers like front and rear. The front contains the location of the first node of the linked list, and the other pointer rear contains the location of the last node. So this is a diagram which shows that the first diagram which shows that only it contains the three elements like 50, 25 and 20. This is a position, we can call it as a front. Here is the position, we can call it as a rear. Then one more element is inserted to this linked list concept. Then we have to creating the new node, then inserting an element into this, then adding to the end of the list, that is to the rear end. Then 70 is a new node are to be inserted into the last node of the linked list. This process we can call it as a NQ. Then the last diagram which shows that 50 element are to be deleted from the front end, so that the front is moved to the next element, that is 25. Then the elements which are 25, 20 and 70. This process we can call it as the DQ. Then we move on to the algorithm for insertion. This process we can call it as an NQ. Let the queue is the linear array containing n elements. The front is a pointer that contains the location of the element to be deleted, and the rear is a pointer it contains the location of inserted in the queue. Here the one variable that is called item. Item is a variable. It is element to be inserted. Some of the steps are to be present here. Step 1. If the rear which is equal to n minus 1. When this condition is become true, the queue is an overflow. Here we have to checking the overflow or not. Here the queue is overflow or not. So that if the rear equal to n minus 1, this condition is checked. If it is true, the queue is an overflow. If it is false, go to the next step. The next step, it checks whether the queue is empty or not. If the front which is equal to null, when this condition is present, here the queue is an empty. So that the front which is equal to 0 and the rear equal to 0, because the queue is an empty. Or else increment the rear pointer so that the rear which is equal to rear plus 1. Then after incrementing the rear pointer, go to the step 3. The new item is inserted to the rear position of the queue, so that the queue of rear which is equal to item. Then step 4 returns algorithm. These are all the sum of the steps for creating or inserting an element into the queue. This process we can call it as NQ. So this is the diagrammatic representation of the insertion of a queue in the link. So in the C programming or in a data structure, the first we have to creating the new queue. This is an empty. Initially, the front which is equal to -1 and rear is equal to -1. NQ is always happens at the rear end. So then the one more element 11. 11 is inserted at the position number 1. So here the 11 element is inserted to the rear end of the list. Next, the one more element, that is a 12. 12 is another element that is inserted to the queue at the rear end. Then one more element 13. 13 is inserted at the element at the end of the rear. Then one more element 14. Then increment the rear pointer and inserting an element to the rear end of the list. Then one more 15. 15 is a new element that is inserted at the rear position. This process we can call it as the NQ in the queue. Then algorithm for deletion, this process we can call it as the DQ. Here, let the queue is an array that consisting of an elements. Front is a pointer that contains the location of element to be deleted, and rear contains the location of the element to be inserted. This algorithm deletes the element at the front position. So here there are the four steps. The first, we checks the condition A, the front which is equal to null. It checks the condition whether the queue is an empty or not. When this condition is become true, the queue is empty. Or else go to the next step, that is a step 2. Here it copies the front end of an element to an item variable. Then go to the step 3. If the front which is equal to rear, here if the queue has only a one element, so both are in the same position, so that front which is equal to null and also the rear is also null. Or else increment the front pointer, then return. This is an algorithm for deletion. So this is a diagrammatic representation of the process of the deletion operation in the queue. So here the queue, it contains the number of elements like 11, 21, 31, 41 and 51. The first, copying the element 11, then delete that element, then increment the front pointer, then copying the second element 21 and increment the front pointer, delete that element and increment the front pointer. Then DQ of an 31, here is that the 31 is for copied item, then it is deleted, then increment the front pointer. Then copy in the 41 element, then it is deleted and increment the front pointer. So the last one here is that it is an empty queue. This process we can call it as the deletion operation in the queue. So these are also some of the different applications of a queue. The first is simulation and various of operating system. That one is a multi-programming platform system and different types of a scheduling algorithm, round robin techniques, printer server routines, various application server software is also based on the queue data structure. At last is operating system for maintaining a queue of a process that are ready to execute, that are waiting for a particular event to occur. These are all some of the different applications of a queue present in the data structure. Thank you. If you like my videos, please do subscribe to my channel, Soumya Tutorials, and click on the bell icon for the notification of the new videos. Thank you so much.